All right, hello. So we're going to be talking about the volume of prisms and cylinders today. It is lesson 18.1 for geometry, 21.1 for math 3. Let's get started. So first off, we're going to be looking at some basic volume formulas. Now, there are definite ways they figured this one out, but if we have the nuts and bolts of it is we have a right prism and a right cylinder. And all that right means is that everything meets at a right angle or a 90-degree angle. So nothing is like tilted. Everything makes kind of what you would expect. Like if you get a box in the mail or a cylinder in the mail, you would want them to be all at like right angles. You wouldn't want anything to be like squished off to one side or tilted off to one side because that usually means it gets damaged. Right prisms, right cylinders, right angles. That's the main thing there. So the formulas, we're going to start with the volume of a prism. Anytime you have, this is your standard box shape, right? It's all made out of rectangles. And your volume is length times width times height. So you guys are all familiar with the area of a rectangle, base times height or length times width. We're just adding height to this, length times width. Gives us the base times height is all of those rectangles stacked together, gives us our final volume. The book does give you this one for the volume of a cube, which is s to the third, side length to the third. That only works when all of the sides are the same, and quite honestly, you can do it with the same equation for a rectangle. So we're just going to use the right rectangular prism equation. All right, let's take a look here. So example 1, we've got this real world problem. We've got a aquarium, all right, and they want us to estimate the volume of water in gallons. And they've given us a conversion. So before we can do anything with gallons, if we look at our picture, all the measurements are in feet. So let's just find our area in cubic feet. Well, that's as simple as length times width times height. I use a cursive L, the book does as well. Regular L's tend to look like ones, so it's just easier to use a cursive L. Doesn't matter which one you consider the length and the width, absolutely not. I tend to make the length the longest side. My width is 60, and my height is 8. But you could rearrange those in any order and still get the same answer because multiplying, you can multiply in any order. 2 times 3 is the same as 3 times 2. All right, so multiply all those together in your calculator, and you get 57,600 cubic feet. Why cubic feet? Well, because if we think about it as adding measurements in there, I'm looking at 120 feet times 60 feet times 8 feet. 1 foot, 2 foot, 3 foot, feet times feet times feet gives me cubic feet. That also, I think of it as the number of dimensions. This is a 3-dimensional shape. That cubic foot tells me it's 3 dimensions. So that exponent of 3 means I'm looking at a 3-dimensional object. Okay, how do I convert it to gallons? Well, we're going to use a little dimensional analysis. We'll turn that equation here into a fraction. Since they're equal, that fraction just equals 1. We just have to decide which way to flip it. So we're looking at that as over 1. So I need the cubic feet part to be in the denominator so that they will cancel out. Cubic feet divided by cubic feet, and my only value left is gallons. Unit left is gallons. So 57,600 feet times 1 divided by 0.134. That tank that they've created will hold 429,851 gallons. The second step is just another conversion to figure out if we want to figure out how much weight that is. We're not going to worry about that one right now. Let's take a look at part B. Ice takes up more volume than water. We know this. So if I fill this cube with water, and then freeze it, how much ice is it going to take up? So they're using this side length, 3 centimeters. You could also just do 3 times 3 times 3. So we're looking at 3 to the third is 27. So that volume of that piece, that cubic ice, or it's a cube of ice, sorry, ice cube, is 27 cubic centimeters. Once it melts, what is my my water going to be? Well, we need to figure out how much water we actually have in its frozen form. Right now it's ice, so its density is 0.9167. So we take that 27 cubic centimeters, and there are 0.9167 grams in 1 cubic centimeter of ice. And if I grab my calculator here, I'll multiply those two together. 27 times 0.9167 means there are 24.75 grams of frozen water. And so that the number of grams will stay the same whether it's frozen or melted. So they rounded your book rounded to 24.8, so we'll keep using that one. Our conversion factor for water, once that ice is melted, how many cubic centimeters of water do I have? Well, I've got 1 gram per cubic centimeter. Other way around. 1 cubic centimeter over 1 gram. So grams cancel out. 24.8 times 1 is just 24.8. So the key new piece here is that volume equation. Then we just brought in a little conversions. How would I find the volume of this? Oh, wait, actually, well, not that one. Sorry, here. Looking at an oblique prism, this is just where I've taken my box and tilted it, or taken my cylinder and tilted it. But here's the thing. The formula stays the same. The only difference is my height is not the side length anymore. It's not that vertical side length. It is literally how tall is it from one base to the next. So they've drawn it out that way. You could also draw it up like this. It's turning that into a right angle. So if I take a look at these, this is what they're saying. Basically, if I take a stack of papers, they're going to have the same volume if I have them perfectly stacked or if I've pushed that stack of papers so it's at an angle. So let's find the volume of this oblique cylinder. So we're going to find the volume, and what we're looking at, they say Cavalier's principle, that just means we can use the height. So they've told us the height is 3 times my radius. So my height here is 3r. Can I find my radius? Well, we know the equation of a circle. Area of a circle is pi r squared. So if my area is 81 pi, pi divides out. 81 is r squared, so I square root those. And my radius is 9, which means 3 times 9, I have a height of 27. So now the volume is the area of the base, which is 2 pi r. They actually gave that to me already. Base times height. So I'm looking at 81 pi times 27. And when you plug that into your calculator, you get 6,870.7 cubic centimeters. Okay, we are going to stop there. We're going to pick up with B next time, and I will see you guys later. Have a good one.